welcome to the Chemistry 75 Labs. Scott and I here are going to give you some quick demos of all of the Chem 75 labs. Today we're starting with the first one, the determination of mass, volume, and density of both solids and liquids, right?
Exactly.
All right. So the first thing that we want to do, density, as we've talked about in class, is a physical property of matter that is often very useful to us. So what we want to do is figure out how to get the density of any kind of solid. We have in a box there, and in the lab you'll get you'll see this box, and Scott's put in here a bunch of different solids, and what we want to do is figure out the density of each one of those. And again, we talked about the definition of density before, and it's in your lab handout too. So to figure out the density of any solid, we need to figure out what the mass of that solid is, and we need to figure out the volume of that solid. So density, as we've talked about in class, is mass divided by volume. Is that right?
Mass per unit volume is exactly correct.
Mass per unit volume. So we need to figure out the mass of this thing and the volume of this thing. Mass isn't that bad, we just have to weigh it. So Scott, why don't you pick a numbered metal sample and weigh it for us.
Okay, when you pick up your samples at first, make sure that you write down the number and the letters on your sample. Otherwise, you will not receive a mark for your sample.
Oh, I didn't know that.
Yeah,
All
it's
right.
a very
That's a good one.
it's very complex. Make sure, for example, this one here is labeled number 6 tin or number 6 SN. So make sure you write that down before you weigh your sample. To weigh your sample, you're going to use one of these scales, the Aculab scales, and before you weigh your sample, you always have to tar the scale so that it reads 0. So when you come to the scale, make sure you turn it on, make sure you hit the tar button, and the scale will return to a 00 value. You're going to place your sample in the middle of the scale and read its mass to the nearest tenth of a gram. So that this one here reads at 69.1 grams.
Perfect. That was great. That wasn't that bad, was it? Putting something on a scale. Right on. So we have the first part. We have the mass of, what number is that one again?
6 SN.
The 6SN. We have the mass of that. Now we have to figure out what the volume of that is. Well, you can tell, let me grab that thing.
Okay.
You can take this thing, and if you remember your grade 9 math, you can figure out the volume of this by doing volume equals pi r squared h and all that kind of fun stuff. But in chemistry, we have access to other volume things, and it's a whole lot funner finding the volume this way, and usually fairly
Simple.
simple. So I'm going to have Scott figure out the volume of this sample using only a volumetric cylinder thing. What do you call this?
Graduated cylinder.
A graduated cylinder.
cylinder.
Get our terms right. You only using a graduated cylinder and water.
Okay. Anytime you're using any sort of chemical glassware, for this example, we're going to be using plastic, just because it is a metal sample going into a plastic tube. Okay, do not use your glass graduated cylinders out of your drawer for this, because they will shatter and break. Okay, what you want to do is you want to fill up your graduated cylinder with the distilled water. Okay, as you can see, if I did it this way, it would probably take me 15 or 20 minutes to squeeze out enough water to fill it up to 70 milliliters. You want to fill it to 70 milliliters. So just remove the top of of the distilled water bottle.
And now why are you picking 70 milliliters?
We're picking 70 milliliters because this graduated cylinder is graduated at 10 milliliter intervals to a total of 100 mils. And none of our objects go more than 30 milliliters volume, so they will fit on our scale.
Gotcha.
Okay. Now what you want to do when you're measuring out your water is you want to make sure the meniscus lands flat on the 70 mil mark.
Meniscus, remember that's in your lab handout there, little pretty picture. I drew that picture, one of them anyway. So look at that for meniscus.
Okay, and so when you get down to this, when you get down to the meniscus resting on the 70 milliliter mark, that's when you can start to measure your volume. of
So
your-
I should record that 70.0 somewhere?
You should, yes, you definitely should. You should record your 70.0 as an initial volume. So your initial volume for this experiment or this part of our measurement is 70 mils.
Sounds
Excellent.
good.
Thanks
Then
for
I get-
reminding me.
Then I get to throw that in there?
Yeah, you just get to drop it in. Well, not really. Okay? What you want to do, now this is very important because you don't want to lose any of this water in this graduated cylinder, otherwise you have a mismeasurement.
Mess up my volume.
Exactly. You want to tilt this on its side, okay, and slowly slide it in. Okay? Because these objects often are quite heavy. So you want to slide it in slowly.
And don't get your finger wet.
No, definitely
Take
don't get your finger wet. And just slide in your object, just like so. Okay? And then you place the graduated cylinder back on a flat surface. Now, this next reading you're going to take is going to be your final volume. And what do you know, this one worked out great. I knew it worked out great before. But anyway, this one works out just great. And if you take a look at my final volume here, it is exactly 80 milliliters. Okay? So,
That's why you picked that one.
that's why I picked that one, yeah. So if we have an exact volume of 80 milliliters, we had an initial volume of 70 milliliters, that makes our volume of our object to be 10 milliliters. And the way I figured that out is quite complex. I took our final volume, subtracted it from our initial volume, and got our volume of our object.
So now to figure out density for tin number, what was it?
6.
Tin number 6, I would just take the mass, which we got before, and divide it by whatever I got for the volume. And the calculations, I think, are in the lab. Okay, so that's all that we have to do to figure out the density of any one of these objects. Figure out how much it weighs, put it in the graduated cylinder to figure out the volume of it, divide the two numbers, and we come up with our density. I think that's good.
Yeah, okay.
Anything else on that one?
No, that one's pretty straightforward.